Characteristics of polynomial from equation. My suggestion is go through the problem, pause the video, answer the questions, and then look into my suggestions. Here are my suggestions. It says write characteristics of polynomial f of x which is equal to minus 3x x minus 2 cube x plus 1 square. Now degree of polynomial. This is given in factored form. So when you multiply all these, then exponent of x is going to be 2 plus 3 plus 1, right? So the degree of this polynomial is 2 plus 3 is 5, 5 plus 1 is 6. So it is 6th degree polynomial, right? What is the name of a polynomial? Name of the polynomial is based on the degree, right? So it is 6th degree, it is called sextic. So it is sextic polynomial. So that is the name of the polynomial. And next question is leading coefficient. Now the leading coefficient here is not minus 3. Actually leading coefficient is minus 3 times coefficients of inside terms. Fortunately for you, leading coefficients remains minus 3 since all these coefficients are also 1. But you need to take care of this, right? We do have an example in this set where it is not so. So that's why I'm kind of alarming you at this stage, and it's a learning experience. So leading coefficient is 3 times 1 times 1, which is minus 3, of course, right? So leading coefficient is minus 3, that is negative, right? And behavior. As you know, and behavior is based on degree and leading coefficient. Since the leading coefficient is negative and the degree is even, both sides are going to go downwards. So the graph is going to open downwards. So as x approaches plus infinity, y approaches negative infinity, and even when x approaches negative infinity, y approaches negative infinity. So x approaches plus or minus infinity, y approaches negative infinity. Number of zeros. Number of zeros you can count from here itself. So there is 1 0, 2 0 and 3 0. Order is of course different. This is order 1, order 3 and order 2. But we're just asking for number of zeros at the moment, so it is 3. Number of turning points. Now to answer this question, it is better to sketch the graph, right? You can of course give number of turning points from zeros also. The formula is number of zeros minus 1, that is we have got 3 zeros. We got 3 minus 1, that is first part, plus number of even zeros. We got 1 even zero. We'll add this. So we get 3 minus 1 is 2. 2 plus 1 is 3. So the number of turning points is 3. Right? Let me answer symmetry. It doesn't seems to have any symmetry. So symmetry is none. But to confirm that point, let us sketch our graph and see, right? So it's easy to sketch this graph. We got 3 zeros. This one is a 0 at 0, right? This one is a 0 at 2, plus 2. Let's say plus 2. And the order of this 0, I'll write here itself. You know, it helps in drawing. Its order is 3. And this one is at minus 1. Let's say this is my minus 1. And the order of this 0 is 2, right? And behavior is, as you can see from here, minus. That means it's a 2. We say 6, right? So even degree minus. So end behavior is like going down here. That is the end behavior. Now when we say that this 0 is of order 2, that means when we are moving over here, we will have to turn from here. It bounces back like a parabola at the vertex. Do you understand? And this is a linear, so it will cross. And this is cubic. So when you're coming from here, it will go like this. So like this, you have to draw. Now, we know the nature of the zeros, we can make the graph. So we just connect these points and say, well, this is our graph for this particular function. So that is the graph. And once you have drawn the graph, we know the turning points. 1, 2, and 3. So these are the 3 turning points which we expected. Do you see that? So that is how you get your turning points from formula or from the graph. I hope you appreciate it. This formula is very important. Normally it is not given in the books. So go through this video and understand how we got the formula from the equation itself. Thank you and all the best.